This is a video about changes to Schrödinger's equation, Planck's constant, as well as a restructuring or modification of E equals mc squared. Absolutely separate variables can be constructed as separate eigenvalues. Planck's constant, as well as the concept of the speed of light squared, can be restated where time is treated as a series of eigenvalues rather than an integer quantity. Now, the reason you might do that has to do with the more accurately descriptive treatment of E equals mc squared. Light travels at different speeds through materials of different refractive indices. With the E equals mc squared version using the speed of light through a vacuum. Now, the Planck's constant is E equals hv, energy equals Planck's constant times the speed of light. Now, if you modify the notion of the velocity of a thing to be distance times time, and you modify time to be made up of eigenvalues, then those eigenvalues can actually predict the existence of accurate refractive indexes, which cause the instantly available energy from E equals mc squared to be associated with the actual form of matter, much like a refractive index, rather than the simplest abstraction of a particle at a vacuum going through radiation. So there's a sense kind of matter unspooling from its actual linked up aggregate form, which can be described if you treat time as an eigenvalue, because groups of atoms will have different numbers of possible interactions which are unique to their geometry, which would form the contents of the matrix that would be used to describe the time eigenvalue of a particular actual little chunk of matter. Then that would be used to modify the E equals hv, because the amount of energy available, well, E equals hv is usually associated with protons, yet I've noticed that Planck's constant is linked to E equals mc squared. Basically, going from single atoms to clumps of atoms to actual matter, you get refractive indices, and I think that treating that geometrical progression with time eigenvalues creates greater accuracy of the equations that describe what matter will do.